friends, welcome to Chandu Smart Class. In this session we are going to discuss about components of block cipher. Before going to learn about DES and AES algorithms, we must know about what are the different components we are using in those algorithms, DES and AES. So DES, AES, all those are modern block ciphers. So now in this session we are going to discuss about different components we are using in modern block ciphers. So first of all, what is block cipher? Block cipher is the cipher which converts a block of plain text to a ciphertext. A block of n bit plain text will be converted using the cipher. Will be converted using the cipher will be converted to n bit ciphertext. So here n bit means we already discussed about block cipher. N bit means either 64 bits, 128 bits, 256 or 512 bits. N bit means either 64, 128, 256, 512. 64 or more bits will be converted to 64 or more ciphertext bits. That is block cipher. Okay. So what are the different components we are using in this block cipher? So first one is P boxes, permutation boxes. First component is P box. So P means permutation. Permutation means transposition. So permutes. So it will reorder the position of the characters. Reorder the position of the characters. That is P box. There are three different types of P boxes. Straight P box and compression P box, expansion P box. Expansion P box. Okay, there are three types of P boxes. Here in straight P box there are n inputs and m outputs are there. So where n is equal to m. In compression P box, n inputs, m outputs, and where n is greater than m. The number of inputs are greater than the number of outputs in the compression P box. And expansion P box, n inputs, m outputs are there, where n is less than m. Where number of inputs are less than number of outputs. For example, if n value is 5, then 5 inputs are there, 1, 2, 3, 4, 5, and 5 outputs are there in straight P box. This is straight P box. So permutation means changing the positions of the characters. So second bit will become the first bit, or first bit will become the fourth bit. Like this. Okay, the number of inputs are equal to the number of outputs, then it is called straight P box. Okay, and what is compression P box? Here the number of inputs are 5, 1, 2, 3, 4, 5, and the number of outputs are less than the number of inputs, and the connection in between the inputs and outputs are assumed like this. Okay, and what about second and fourth bit? Those two bits are neglected. Okay, those two bits are neglected, so only 1, 3, 5, these three bits go into output. Okay, this is compression P box. Okay, and next one, expansion P box. There are three inputs, 1 2 3. There are 5 outputs. Okay, the number of inputs are less than the number of outputs. Here some bits are repeated in the output. Some input bits are repeated in output bits. Okay, so 1 2 times and 3 2 times. So this is expansion P box. These are the different types of P boxes: straight P box, compression P box, expansion P box. In straight P box, the number of inputs are equal to number of outputs. In compression P box, the number of inputs are greater than the number of outputs. In expansion P box, the number of outputs are greater than the number of inputs. Out of these three P boxes, what are the invertible components and non-invertible components? Invertible P box or non-invertible P box? First of all, what is invertible? Invertible means if you get the inputs from the outputs. The normal component means we are getting output from the inputs, and invertible means if output is there, if we get the input from the output, then it is invertible. Okay, so normal component we will get output from input. In invertible component we also get input from the output, then it is called invertible component. So if you observe this straight P box, the number of inputs are equal to number of outputs, then here you will get the invertible component also in the reverse processor. So first bit, second bit. First bit will become as the second bit in invertible component, and second bit will become fourth bit in invertible component, and third bit will become fifth bit, and fourth bit will become first bit, like this. This is invertible component. This is invertible component. And if you observe the compression P box, what about the second and fourth bits? Okay, so it is not reversible. It is not reversible. So if you have outputs, then you cannot get the input. It is not possible to get the input. Okay, so what we will write in second and fourth positions? So you don't know. So that's why it is non-invertible component. And in the same way, if you observe this, suppose if you have output bits, then do you get input bits? Which bit need to take as the first bit? Okay, so either first bit or third bit or second bit, you don't know. So that's why it is also non-invertible component. Okay, in these three types of P boxes, one straight P box, whatever the straight P box is there, that means the number of inputs are equal to number of outputs, then it is invertible component. And if the number of inputs are not equal to number of outputs, then it is non-invertible component. That means compression P box and expansion P boxes are non-invertible components. Okay, you can use that invertible component in the decryption process. Okay, so you cannot use non-invertible components in the decryption process, so you have to fix that one. What are the inputs neglected in outputs, and what are the inputs repeated in the outputs? You need to mention those while doing encryption and decryption process. So this is about P box. And next component of block cipher is S box. S box. S means substitution box. Okay, we are going to substitute another bits or another characters. We are going to substitute another bits. So here also the number of inputs and the number of outputs may or may not same. Okay, like P boxes, permutation boxes. Here also S boxes are three types. Straight S box, compression S box, expansion S box. So what is straight S box? So here we need to draw a table for S boxes. Okay, and you need to assign some index values for rows and columns 0 0 0 1 1 0 1 1. So here we need to take the table and you need to assign index values for the rows and columns, and you need to fill the cells, table cells, with some random values 0 1 0 0 1 1 1 0 0 1 0 1 0 0 0 0 0 1 1 1 0 1 1 1. Okay, total 8 cells, 8 values. So if the input value is 0 1 1, then what is the output value of the S box? This S box. So you can write this table anyway. Okay, so you can write with different values. Any values can be filled in the table. Okay, so 0 1 1. So 0 first value representing row and second 2 bits, 1 1 representing column. You can take any one. 0 1 is representing column or 1 is representing row. So I am taking first bit representing row and other 2 bits representing the column. Then 0 0 row 1 1. So what is the output value? 0 1 0 1. This is the output of this S box. Okay, the number of inputs are equal to the number of outputs. Okay, this is straight S box. Okay, then what is compression P box? Compression means the number of inputs are greater than the number of outputs. 0 0 0 1 1 0 1 1 0 1. So here the cell which contains only 2 bits 0 0 1 1 1 0 0 1 0 1 0 0 1 0 1 1, like this. If the input is 0 1 1, then 0 1 1, output is 0 1. This is compression S box. Here the number of inputs are greater than the number of output bits. It is called compression P box. Expansion P box. Expansion P box. Suppose if this is the table 0 0 0 1 1 0 1 1. Okay, here 0 1 0 0 1 1 1 1 1 and 1 0 0. The input is 1 0, then the output is 1 1 1. Okay, the number of inputs are less than the number of outputs. expansion, it is expansion S box. Okay, so total 3: straight S box, compression S box, expansion S box. Okay, out of these 3 components, this is the invertible component. The number of inputs are equal to number of outputs, then it is invertible components. We will get input from the outputs also. Okay, so you can take 0 1 0 output, then you will get 0 0 0 as the input. Okay, suppose for example if you take 1 0 0, if assume this is output, then what is the input of 1 0 0? So 1 0 0, here it is, then input is 0 1 0. 0 1 0 is the input. We will get input from the output, then it is invertible component. But here we will not get input from the output. Suppose if you take 0 0, if you take 0 0, then here 0 0 is available in 2 cells. Which one we need to take? 0 0 0 or 1 0 0 0 1? Ambiguity is there. So that's why it is non-invertible component. Okay, and expansion P box. So you see this is also non-invertible component. Okay, so suppose if you take 0 1 1, if you take 0 1 1, how will you get the input? 0 1 1 0 1, there is no process to get this one. Suppose for example, what is the invertible table for this one? So you can draw invertible table for straight S box. 0 1 0 0 0 1 1 0 1 1. So 0 0 0 for 0 0 0 1 0 0 1 1 0 0, and for 0 0 1 1 1 0 1 1 0. Like this we can get the invertible component for straight S box, but it is not for expansion or compression P box. So how you get 0 0 0 1 1 0 1 1? So 0 0, how you get? Here input values have 3 bits, but here the input values, index values are 2 bits. So there is no process for inverting this component. That's why this is non-invertible component. Okay, so straight S box is invertible component, other 2 S boxes are non-invertible components. And next component is XOR operation, exclusive OR operation. So XOR operation means, suppose if X Y is there, X XOR Y, 0 0 1 1 0 1 1. So 0 1 1 0. Okay, so how you get? So just add addition operation. You need to perform the addition operation. 0 0 0 0 0 1 1 1 0 1 1 1. For addition 1 0, 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1 0. Okay, in binary addition 1 plus 1 1 0. We need to neglect all these carry bits, then whatever the bits are there, that is exclusive OR operation. If both input bits are same, then the output is 0, otherwise output is 1, that is exclusive OR operation. So here the exclusive OR operation is called self invertible component. Why will we call it as self invertible component? XOR operation. Suppose for example, if X is there and key is there, K, so we will get some Y. Okay, so what is self-invertible component? Output is Y. If we perform the same operation, exclusive operation, with output and K, we will get X. That's why it is self-invertible component. Okay, so in encryption process we need to suppose in encryption process we need to give the secret key, the same secret key in symmetric key cryptography. So X XOR K, if it is encryption, then in decryption also we can do the same process in decryption process. So with the output Y and exclusive OR K, we will get the input. For example, if X is equal to 1 and K is equal to 1, so 1 XOR 1 is equal to 0. Okay, and whether we get input, if the output is there, then 0 XOR the same key, we need to use 1 is equal to 0 XOR 1 is equal to 1, that is input. Okay, that's why we call it as self-invertible component. Exclusive OR component is self-invertible component. And next component is shift operation, circular shift operation. So circular shift operation means, suppose if there are bits 1, 2, 3, 4, 5 bits are there, circular shift of 2 bits left, circular left shift or circular right shift. Circular left shift means left 2 bits. So then output is, if you perform the circular left shift of 2 bits, then output is third bit is there, fourth bit, fifth bit, and first bit and second bit. This is the circular shift operation, circular left shift. And next component is swapping. Swapping means divide the input into 2 halves, and first half and second half, exchange the first half and second half, that means swapping. Okay, so these are the different components using in modern block ciphers. And next thing is product cipher. This is the most important one, product cipher. So what is product cipher? Product cipher is a complex block cipher. Okay, here we are using P boxes, S boxes, and other components. Whatever the components we have discussed, those are other components. Product cipher is a complex block cipher. It is a combination of permutation boxes, substitution boxes, and other components like exclusive OR, circular left shift operation, a circular right shift operation, swapping, split, combining. These are all other components. So combination of all these components is called product cipher. Okay, so every product cipher, it is a complex block cipher. It must achieve confusion and diffusion. Every product cipher must follow two properties, confusion and diffusion. Okay, so confusion means confusion which hides the relationship between ciphertext and key, cipher key. Okay, diffusion means which hides relationship between ciphertext and plain text. Okay, that means if there is any change in key, one bit change in key, more or all bits will be modified in the ciphertext. And here the plain text, if one bit change in plain text, there will be more number of bits or all bits will be modified in ciphertext. Okay, that is confusion and diffusion. Every modern block cipher must achieve these two properties, confusion and diffusion. So every block cipher must achieve these two. Okay, and so how you achieve confusion and diffusion, these two properties? So these two properties can be achieved with the help of P boxes and S boxes. P boxes and S boxes. Okay, and next one is every product cipher must have rounds or one round. Okay, so each round has P boxes and S boxes. These rounds are used to achieve diffusion and confusion. Diffusion and confusion. These two properties can be achieved with the help of iterated product ciphers. Okay, so if you use the product cipher repeatedly, then you can achieve diffusion and confusion. Okay, in every product cipher we have P boxes and S boxes. So with the help of P boxes and S boxes, we will achieve the confusion and diffusion. Okay, so based on the algorithm, we can use the number of rounds. Okay, and product ciphers are two types. Product ciphers are two types. Feistel cipher and non-Feistel cipher. Feistel cipher means which has self invertible and non-invertible components, and non-Feistel cipher self-invertible components and invertible components only. There are no non-invertible components. Okay, so Feistel cipher is a product cipher which contains self-invertible components, invertible components and non-invertible components. And non-Feistel cipher is a product cipher which contains self-invertible components and invertible components only. Okay, these are the different components of modern block ciphers. I hope you understood. So if it is helpful to you, please like, share and subscribe. Thank you. Thanks for watching.